Hi guys, welcome to our channel Shubhada Group of Education Sirsi. You are watching Satish Sir's physics videos for Karnataka CET and NEET. So it is a problem on geometrical optics. Frequencies of light incident on a system of scattering particles are in the ratio 1 is to 2. Then the intensity of the scattered light in a particular direction is. Okay, so here, as you know that according to the Rayleigh scattering, you know that intensity of the scattered light is inversely proportional to 4 through the power of the wavelength. As you know that wavelength is inversely proportional to frequency, it implies that intensity is directly proportional to 4 to the power of frequency here. So therefore I can take I1 is to I2, that must be equal to 1 by 2 to the power of 4. That is equal to how much? 1 divided by 16. 1 is to 16 is the right answer for this question. Okay, the next problem says that a ray of light is incident at an angle of incidence I on one face of a prism of angle A. This is assumed to be very small and emerges normally from the opposite face. If the refractive index of the prism is mu, the angle of incidence I is nearly equal to. Okay, so whatever the problem comes on prism, let me use this ray diagram. Okay, for this one, this is of the angle of incidence I here, and here is what the refraction of light, and this is r1, and again here is okay, and here it should be r2, okay, and here is the emergence, angle of emergence E, and this is what the angle of deviation delta. Okay, this is what I will take angle A, B and C here. Okay, so I will consider this ray diagram for each and everything, if any problem comes on prism. Okay, so as you know that it is given that the formal for normal incidence, right? Incidence I on the one face of the prism, which is emergence normally up. Okay, so clearly it is given that normal emergence E equal to 0. So if E equal to 0, I can take R2 must be equal to 0. So R2 is here, okay, R2, and here it is R1. Okay, here it is R2, and this is the deviation delta I as well as emergence, angle of emergence E. Okay, so now as you know that R2 equal to 0, so therefore I can say that A equal to R1 plus R2. This is the condition I have discussed in synopsis. So therefore I can say that A is going to be what? R1, as R2 is equal to 0. Okay, let me use the Snell's law here for the first phase. This for sine of angle of incidence to the sine of angle of refraction at the first surface. For this surface, okay, this is equal to refractive index mu, correct? So therefore r1 equal to a, right? R1 equal to a, so therefore sine I equal to mu into sine r1. Clear? This is clear to everyone? So therefore I can say for small angle is given r1 equal to a mu into sine a, as you know that sine a is nearly equal to a. So therefore I equal to, what is that? I equal to mu into a. Option A is the right answer. Okay, the next problem says that a ray of light is incident at a 60 degree on one face of a prism of angle 30 degree, and the emergent ray makes 30 degree with the incident ray. The refractive index of the prism is, okay, so here again same type of the problem. Let me use this relationship. I plus E must be equal to A plus delta here. Okay, in the sense angle of emergence E must be equal to, how much is given here? So it is 30, emergent ray is also 30 minus 60 degree, so that is going to be 0. Angle of emergence is going to be 0. If angle of emergence is 0, then R2 must be equal to 0, right? So therefore I can say R1 plus R2 equal to A. It implies let me use R1 is equal to how much now? R1 equal to A, that is what? 60 degree, right? Equilateral prism is given, or how much? R1 is going to be, sorry, not A is 30 degree, correct? This is what makes an angle 60 degree. So that's the reason why R1 must be equal to 30 degree here. Okay, so it implies, let me use the Snell's law again, mu equal to sine I divided by sine I R1. So it is equal to sine 60 divided by sine 30. It is equal to how much? It is root 3. Try to get the value of root 3. 1.33 it seems. You'll get it as 1.33 it seems. Whatever. Root 3 is the right answer for this. Okay, get the solution for that. No problem. You can do it. Okay, so let me go to the next problem now. It says that a thin prism P1 with an angle of 4 degree and made from glass of refractive index 1.54 is combined with another thin prism of P2 made from the glass of refractive index 1.72 to produce a dispersion without deviation. The angle of the prism P2 is, okay. See, as we have studied that dispersion without deviation, it is a condition. What I have seen is angle of A1 A2 that must be equal to, okay, this is the angle of the prism A1 P1 and P2 that must be equal to here mu, I can take it as mu 2 minus 1 divided by mu 1 minus 1 here. It implies A1 is 4 degree, this is what 4 degree is given, divided by A2 we need to calculate, that is equal to mu 2. Mu 2 is nothing but, okay, that is what 1.72, right? 1.72 minus 1 divided by 1.42 minus 1, right? 0.54, sorry, this is 54. 1.54 minus 1. Okay, so therefore I will get A2 as how much? This is what 0.54 divided by 0.72 into how much? 4 into 4. That will lead you to get the answer as how much? 3 degree. 3 degree. Option B is the right answer for this question. Okay. If the ratio of the amounts of the scattering of two light waves is 1:4, the ratio of their wavelength is, okay, as you know that the intensity is given, it seems, the ratio of the amount of scattering of the two light, so that is what I1 divided by I2 is given as 1/4. As you know that I is inversely proportional to lambda to the power of 4, so therefore I can take lambda 1 divided by lambda 2 equal to I2 divided by I1 to the power of I2 divided by I1 to the power of 1/4. So that is equal to, okay, so that is equal to how much? Please try to get the answer now. 4 divided by 1 whole to the power of 1/4. That is what root 2 divided by 1. Root 2 is to 1 is the right answer. Option B is the right answer for that. A ray of light incident normally on one of the face of a prism of angle 30 degree and refractive index is root 2. The angle of deviation will be, okay, for this one on one face, okay, let me use a different ray diagram here, okay, say that it is what incidenting normally, I must be equal to 0, so therefore R1 is going to be 0, okay, so it will be like this, and this is what R2 emergence E, and it will go like this, and this is what deviation delta now. Okay, so now this is what angle ABC here like this. Okay, so clearly it is given that prism of angle is 30 degree, okay, and the refractive index mu is equal to root 2 is given, and we know that A equal to R1 plus R2, so R1 is going to be 0 and 0 plus R2, it implies A equal to R2 equal to how much? 30 degree. Clear? So therefore I can use 1 by mu equal to, so therefore 1 by mu equal to sine R2 divided by sine E. It is the this is what actually I am applying the Snell's law to second surface AC here. So therefore I can say that 1 by root 2, that is equal to sine R2, correct? So now sine R2 is going to be 30 degree, sine 30 degree divided by sine E. So here I will get the value of angle of emergence here by using sine of angle of emergence. So it implies E equal to 45 degree. Okay, so that I will get 45 degree. Question is to find out the value of deviation. As you know that deviation equal to E minus R2 and 45 minus 30 degree is going to be 15 degree. So option D is the right answer, 15 degree. Okay, the next problem says that if the refractive index of a material of the equilateral prism is root 3, equilateral prism in the sense A must be equal to 60 degree, then the minimum angle of deviation of the prism is, okay, simple problem, mu is equal to sine of A plus delta divided by 2 divided by sine A by 2. So it implies root 3 equal to sine 60 plus delta divided by 2 divided by sine 60 divided by 2. Okay, so therefore root 3 divided by 2. Okay, by using this one, as you know that sine 60 is 1 by root 1 by 2, 1 by 2. So that's the reason I'm taking that to LHS now. Root 3 by 2 equal to sine 30 plus delta by 2. Okay, so making simplify now. So therefore just simplify it. So to get the value as sine inverse of root 3 by 2, in the sense it's 60 degree. 60 minus 30 is how much? 30. 30 into 2 is 60. So delta is equal to 60 degree. 60 degree is the right answer. Option C is the right answer for this question. So anyhow, thank you very much for watching this video. Please do like this video. Please share this video with your friends and colleagues to support us. Please do subscribe to our channel. If you have any doubts, please make a comment in the comment box so that I can help you with. Wish you all the best for your examinations. Very good luck.